All right, good thing is we're the last ones of the day, so we can stay till 4 o'clock. And there's Rick Anderson and Larry Young hiding in here somewhere who welcome all questions afterwards. Larry's in the back. Rick is entering now. All right, we're going to talk about the utility network. Based on everything the utility network provides, we could spend 5 days. But we're only going to talk about tracing and geoprocessing. So the data set I'm working with today has been provided to us by Sempra, San Diego. And this has been a data set we've been using the last couple of years to help configure, prototype, and build out the utility network conceptually on how things operate and work. So I've become quite familiar with this data. And sadly, when I have to go to San Diego and I drive around Old Town or the downtown area, I can pick out things based on this demo set. So my wife thinks I need a better life. So the first thing we're going to look at, right? We're zoomed in. Here's an area. There's multiple circuits. We're in an electric domain. And what I really want to kind of highlight is not necessarily domain-specific capabilities, because you need to keep in mind if you're working in a water or gas or wastewater, your traces would be slightly different based on what a subnetwork represents in gas might be a pressure zone. So in electric, we're looking at specifically circuits that are based on phasing, so it's more North American centric, in case there's many Europeans in the audience who have a different type of network to represent their circuits. So what I want to show you, we'll start off with some just basic tracing capabilities. So I zoom in, and what I can do, how many have actually had a chance to play with the utility network? Just a couple of you. Hopefully many of you have already gone by the kiosk maybe already during the last couple of days and asked questions. We do provide, when you receive ArcGIS Enterprise 10.6 and Pro 2.1, we have asset packages with sample data. It's our favorite Naperville sample data set. It's at least a starting point where you can start to play with already data that's loaded for you, pre-configured, so you can get introduced to the concepts. So one of the things we'll look at is doing some tracing. So in Pro, whenever you select any layer in the table of contents, you'll see that the utility network ribbon is activated. It's enabled. Within this ribbon, we have tools that are specifically used for tracing. We have the ability to set starting points and barriers for trace locations. So I'd hope if you've had experience with the geometric network, same concept, right? You had a starting point, nice little flag or a barrier that's going to cause the trace to stop wherever you place those. And then what we also have are these gallery of different types of traces. Now you have to remember, again, I kind of put an emphasis on this, is that the utility network is agnostic to the domain or the utility that you're working with, be it gas, electric, wastewater, right? So based on how your utility network is configured will be how some of these tools will actually behave for you. So we're going to do what's called a subnetwork trace. And whenever you launch any of these specific tools in the gallery, well, they do what you would expect. It starts a geoprocessing tool. Now, remember, because Pro itself can be configured by using add-ins. You can also remove tools from ribbons. You can add your own custom tools to ribbon. So what you see in Pro here, when you actually start working with the utility network, and if you're using ArcGIS Pro and you buy maybe a solution from a vendor, you may not see any of this on that ribbon because they may give you specific add-ins that are performing these same type of operations, but are essentially pre-configured for you. So I want to really introduce some of these concepts. So we're doing a subnetwork trace. And a subnetwork, given your domain, and because we're electric, represents a circuit. So for you electrical folk, that's a circuit trace. So here you can see in the geoprocessing tool, Because it's launched from my active UN layer, and we already have a question up front. The resolution, are you not seeing it all? Because I can't see anything over there. The text is fuzzy. Oh, man. It's going to crash the whole demo. Okay, what do you think? Change the resolution? Lower it a little? Thumbs up, thumbs down. Okay, we're going to keep it there. All right, where are we now? We're going to dock this. We're still good? Okay. Oh, I thought it preserved it, unless you said not. Oh, keep changes. What a failure. All right, we know it works. Keep changes. All right, back to the demo. Thank you for pointing that out. At least we can answer one question. All right, we're back to doing this trace, and we're going to do a subnetwork trace. So you can see the tool supports different trace types. Because I launched the tool from the ribbon, we know we're going to do a subnetwork trace. But ultimately, you have all the same choices here that you see up in the gallery itself. All right, part of this, when I'm working, we have to specify what domain network. Now, a utility network contains one or many domain networks. A domain network, in this case of electric, is my distribution domain network or my transmission domain network. Sometimes utilities, maybe a small co-op who manages both electric and water, could actually combine each of those as different domain networks all within one utility network. The power here, because it's all one utility network, we can actually start tracing across these different domain networks. Whole different topic for a different day. All right, so we're going to do this trace on the electric distribution. Now again, the domain networks can even further be defined in tiers. So for distribution, for those who know electric well, we have things called subtransmission. We have features in a substation, right? These are those local distribution substations you might see driving around your neighborhoods. We have medium voltage and low voltage. All right, I want to do a circuit trace which is specific to my medium voltage. Now at this point, I can also choose the subnetwork name. And I'm going to choose one of my favorites, 107. And these are the actual circuits in San Diego. And we have also many choices here about including containers and structures. Well, because the utility network also pulls in the structure network, it's all one network. It's very easy then for our tracing to include, to know what poles are supporting the medium voltage lines based on what's been attached. Or if I know what devices are contained within assemblies or the substation. So very rich modeling capabilities. These are one of these advantages of what we're trying to model the real world in as much detail as possible and have it all part of our topology so we can do better analytics. All right, so you can see there's lots of choices here. There's choices about traversability as well. So let's just go ahead in the meantime and run that real quick. And all we're doing is because we specified the subnetwork name 107, it knows, it looks up, what is the starting point? Where does circuit 107 start? And that's the circuit breaker in the actual substation, and it just traces all the way out. Right, and there's our result, almost 3,000 features. And if we came over and we actually looked at our selection sets for all our different layers, if we look at the distribution device, you can see here's the breakdown of each different type of device and the number of features selected for that circuit trace. On a side note, you're actually looking at the new subtype layer, an optimized way for us to be able to retrieve data from the data source in fewer number of trips, but still have all the different layers. Another topic, another day. All right, so how did we just derive that trace? First things we need to know about the utility network. When we configure it for each of these tiers, we define the definition of the tier and the subnetwork. Remember, a subnetwork in this case is the definition of the circuit. It says it starts at this specific circuit breaker, which is the subnetwork controller, and it knows to trace out in the direction based on its load side, the medium voltage circuit, and it will stop anytime it encounters a device which is open, like a switch or a fuse. So that property here, if we look at the traversability, we can see, it says a condition barrier. Device status is equal to specific value open. What's important here, the device status is a network attribute, right? These are, again, things that are configured. Now, what's happening is when we actually selected the subnetwork trace and we provided the information about electric distribution as our domain network and our tier, once this tool told the system what tier, it automatically grabbed the trace configuration from the utility network and set all these properties. A user wouldn't need to know how to do that, right? Because it was configured into the system. Now, another thing that's also included in this configuration is phase management, right? So as we trace, we know what phase of lines that we're tracing. Is it an A phase and a 3 phase and so forth? All right, so one of the things you might think right off the bat is, wow, there's a lot of options there that a user may need to know to configure. Well, we're building up to that part of the story here in a second. Now, the other thing, right, we talked about setting trace locations. So let's go ahead and add one here. We're going to snap it to that line. As we snap it to the line, come on. Why isn't that working? There we go. Okay. So that green dot represents the starting location. Now, if we go back to our geoprocessing tool, right, you saw how in that case I provided a specific subnetwork name. Well, if I don't know the subnetwork name, essentially remove that, and now I repeat the trace, of course, I'm going to get the exact same result set, but essentially we're tracing given a tracing point as the input. Exact same operation, same trace, same result set. Right? See the difference there? So sometimes users, knowing in their domain, hey, I need to see a circuit report for a specific circuit that may be encountering a fault, or want to know the number of customers. I can go by name, or I can place a starting point on the map. All right, now let's go ahead and clear this. Let's say we want to get a little bit more interesting. We want to do an upstream trace from that same location. So again, by clicking there, the tool reloads. Essentially, we've removed everything. Now we're specifying upstream. I'd have to specify these same properties that we said before. It's medium voltage. And in this case, did the exact same thing that we did last time. We pulled in the trace configuration automatically based on the tier, so we know where to stop. We can include containers. Let's just go ahead and run that. And as you would expect, as this runs, from that starting point, we're tracing upstream on the circuit, and it's going to go back to the substation itself as it completes. Let me dock that. And you can see it selected 117 features. Now, in the current release, we're returning full features. So as you can see, one of the things, if you're an observant crowd, if I come in here, are you guys observant? Or it's the end of the day? All right, you can see, remember my starting point was here, but it returned these entire features, even though the trace came across here and then went upstream, because that is one entire feature. That's why it's returning the entire feature. We're going to do work in upcoming releases where we can return portions of the features, as long as when you're tracing, given your starting point, to know how far along it is on the line or the edge, to only return those features truly upstream, not necessarily all of the entire feature. So we can't do everything in the first release. That's right. We have multiple releases, more functionalities coming. All right, so that was a pretty cool trace. But let's say in this electric world where I need to do a trace, but I need to stop the trace at a protective device. In electric, a protective device are things like fuse. So if there's a surge or something, just like a fuse in your TVs and your electronics, it pops open. So from that location, what I need to do now, these are some of the configurations of doing a trace. The reason we like to say configuration, not programming, In the geometric network, if you wanted to write these type of traces, you had to go into Arc objects and use what was called our forward star cursor. You really had to know how graphs worked. It was a very computer science oriented model. Well, even though this network and topology is very similar internally to what the geometric was doing, but we've built a much better user story around this, that you now create trace configurations based on what the type of traces you want to perform, because you don't have each of the features in the topology. So when you do that trace, you're calling to the REST endpoint. The utility network is all services based, right? This tracing is not happening inside the client application. That trace, based on the configuration of the GP tool, or if you're using the managed SDK, there's a session tomorrow morning at 8:30 on the utility network managed SDK. That's actually just being sent to the service, to the REST endpoint, to where it processes and performs the actual trace, and based on what features you want back, it returns it to the client. So very powerful distributed processing in that case. All right, back to this story. I want to trace upstream, but I actually want this to stop based on a protective device. Now, one of the things in the utility network that we have in the configuration again are categories. A category is just a tag that's assigned to devices, assigned at the asset type level. It's just a string. It's a property that helps describe the feature and what it represents. Well, it's important because those categories can then be used as part of my trace configuration. And what I'm saying here is I'm doing an upstream trace, and I want to specify to stop at a value, a tag, which is of type protective. And now when I run this trace, you'll see based on this trace starting location, it is going to stop at the first protective device it found, which is that fuse. Right? Make sense? That's how easy it is to start configuring how you want to do very advanced tracing analytics. It's all about configuration, no programming. Okay, that was a protective one. But what if I actually don't want protective, but I want to disconnect? Well, same concept, right? Well, the only difference here is I have a category that I created named disconnect. It can be called XYZ if you want. The fact that that category is assigned to a specific type of device is what the trace is looking for to know to stop at that location. So I went previously from a protective device, which are fuses, or maybe an elbow for an underground transformer, to a disconnect device, which is a switch, meaning I manually have to disconnect or open this device to stop a trace. Right? Because I'm going to dispatch a crew to that location if it's not an automated type of SCADA managed device. So there you saw the trace now stopping there. All right, let's clear that example out. We still have 12 minutes. I've been going quickly. Any questions? Pause for some questions real quick. The question was, the point that you saw is the trace starting location. In ArcGIS Pro, that's just a graphic. And that graphic right now in Pro is just that based on that feature. Through the SDK and the trace configuration, we have what's called portioned along. So you'd actually give it the feature and the distance along where you'd want that starting point to actually perform the trace. So that's what I was talking about before. Pro hasn't caught up to what we can do in the trace itself. Question is this all web services? Correct. Yep. Good. Question was, because this is a services-based application, maybe I'm dispatched and I don't have connectivity to my network, right? I'm going to be out on my device. The current release of the software, because it's services-based, is all based on a connected model to the REST endpoint. We are building sync and offline capabilities in upcoming releases that will allow you to take all or a portion of your utility network off into a mobile runtime geodatabase, which of course is just sync, download. Same concepts that we have in runtime with sync. It's just the fact the utility network will come with those features. And then those apps, when doing a trace, will run against the local data set. Yes, that's the power, the offline. We're getting there. A couple of releases, it's coming. Because we actually have to port the entire utility network information model to mobile. So there's a little bit of effort involved. All right, another powerful type of trace. And we can only go over, this is my last trace configuration example because we're going to build into using geoprocessing in a model builder and configuring that gallery. So the last one I'd like to show off, right? So given that trace location, let's go ahead and clear my results. Let's see if I can pull this one off. I'm going to have a filter function barrier. The last one was a filter barrier, which said, hey, just stop at these specific conditions. A filter function barrier means, hey, as the trace is proceeding, do some type of function to derive a value, and once you meet or exceed that value, stop. So let's just do a simple one where we're going to add, let's see if I can get this right, the attribute I'm going to use. Now, the attribute is a network attribute. We can support as many network attributes as you want. If you're familiar with the GN model, we had network attributes, network data sets have network attributes, same concept here. It's all part of the configuration. The ones that we provide, at least 2 of them out of the box, is a subnetwork controller, right? That was that circuit breaker I talked about. When something is set as a controller, there's a network weight, network attribute that tells us this, as well as the shape length to all the lines. It's naturally a network attribute. So I'm choosing the shape length, and what I'm going to do, includes the values is greater than or equal to, and let's just put in 400, and I'm going to check this, use local values. And now when I run this. So what we're doing that same upstream trace, right? We have to discover the direction of the circuit. We're doing the upstream trace. Let's pan over real quick. And what happened here was from that given start location, what I was telling the trace to do, trace until the shape length exceeded, it was equal or greater than 400 units, right? In my case, my data is in feet, therefore the length of each line was being summed together, and now the trace stopped at this last line because it went 400 feet. So this is really demonstrating the power of the configuration of these tools. Now, would an end user need to know all of this, right? You don't necessarily want to teach the guys who are using the software every day, right? You want to build and deploy tools or write applications. Everything you saw here, because it is just a trace configuration, you could do today via JavaScript and calling the REST endpoint. We just had a really nice blog posted by Hussein that showed how a developer could do this. So Pro is not your only client at this release. You can start building JavaScript and runtime applications that work with these REST endpoints. Don't forget those capabilities. All right, so again, I don't want to be a user who has to know to do all of this. So let's look at what we're going to do. We're going to build a model real quick. If I go to Analysis, I can come to Model Builder. How many of you have used Model Builder, right? So I'm not going to teach you anything new here. So all we're going to do is take this trace in here. We're going to drop that trace. It's the exact same geoprocessing trace tool, right? And now we're going to come in here and look at its properties. Let's double click on the trace. Input utility network. I'm going to say it's from the map. And there we go. The type of trace I'm going to do a subnetwork trace. And I'm always going to do electric distribution, and my tier is always going to be medium voltage. And I'll let the user input the subnetwork name. I hit OK. Let's go ahead and now save this. Where are my properties? Come over here, and we'll call this model simple circuit trace. simple circuit trace, hit OK. Go ahead and hit save. Now let's go ahead and run this puppy. Running it right now, it's going to come back. Oh, because we actually did have, because I had a trace starting point, I didn't have to provide a subnetwork name, so you essentially just saw that whole tool run for me. Let's close that, save that. All right, if we come over to my catalog toolbox, right, I just want to show you this. Simple circuit trace, let's open that puppy up. Oh, parameters. I already forgot my first example. Not model builder. I'm going to go back to my model. I forgot to give a parameter. Go back to simple circuit trace. Let's go ahead and edit this. Create variable from parameter, subnetwork name. Where is it? Subnetwork name. All right. Go ahead and save that. Now we can close that back out. We can come back in here, double click that. Oh, why didn't it refresh? That was a complete fail. Come on. Oh, it does not pick up my parameter that quick. All right, we're gonna bail on that. But essentially, for those who know Zoom models, takes a parameter, the tool would have opened, it would allow me to pick the subnetwork name and have run. So that's demonstrating how easy it is to do that. But we're going to come back to some more advanced models. All right, because we really only have, I'm going to take it 5 minutes long, 3:35. Is that okay? All right. Now, one of the things that we did, because we know the gallery to an electrician, or if you're a gas engineer, you don't know what a subnetwork trace is, right? You may know what a pressure zone trace is, or you may know what a circuit trace is. So our gallery is actually customizable. So I can come in here and I can say, oh, I don't want this subnetwork trace. Let's remove that. I'm going to keep these. I'm not going to do a shortest path. I can remove that. I can hit OK. And now, of course, it's a gallery, right? I only see those tools. But let's say we wanted to customize the gallery and start now building this out with tools like the one I had just built. But I'm going to choose another one that I have done. Oh, come on. Medium voltage circuit trace. I'm also going to move this to the top because it's frequently executed. Now, we're just in the geoprocessing framework here, nothing new. One of the nice things to know that they're working on is the ability to have a different icon with the type of tools that you want to add in the gallery, so you don't have to see this crazy hammer every time you want to run this. So there it is. There's my medium voltage circuit trace. Because I'm an engineer, I can go ahead and click on that. And now this tool is essentially running my model, my tool, as it opens up. Essentially because this tool has the parameters properly set. So now I can go back to my circuit name and I can see, oh, there's all the list of my circuit names. I could run it if I wanted to have a trace location. I could have run that as well, which I'm going to erase all of those for now. Now, in my tool as well, I provide options to return the structures. Do I want all the poles to come back and all the pads, all the things that the circuit is attached to? Do I want to include the containers like the substation or assemblies that contain the devices? Now, another thing that's pretty cool about this tool that I've built this to run a circuit trace based on different seasonal configurations of my circuit. I have the current operational circuit, right? That representation is essentially the same as the subnetwork trace that I just did. What does the GIS believe is the current circuit representation of 107? What switches are open? Which ones are closed? How are the phasing all configured? Or I could actually run this trace and say, no, I'm more interested I want to know what circuit 107 looked like during the summertime. So I can go ahead and hit that, and now I can run this trace. Now, as that trace is running, it's essentially doing the exact same trace. But all I had to do in this trace configuration was to tell the trace to look at a different device status attribute. Remember that first device status attribute I showed you in the very first subnetwork trace was just a field, a network attribute. Well, to show the summer trace, I simply have another field on my devices table that represents the state of those switches as they should be in summer. And yet a third field that says, what is the state of the switches in the winter? And that's because the electric company, they rebalance the circuits based on the seasonal load. Air conditioning based in the southwest versus heating in the northeast, right? So they have to know all these things based on what they expect the load to be at that time of season. So here it showed us the result. And what I actually also have, if I can get this quickly configured, turned on for you. If I come over here, I've got layers configured. I'm going to turn off my operational circuits. And in the summer circuit, I'm going to come on and I'm going to zoom out. Let's see. So there is the summer circuit, right? And you can see the summer circuit for 107, it doesn't include this subdivision and it terminates right there. So now if we actually repeat this on the normal winter circuit configuration, we rerun the trace. It's going to do my trace and it's going to select the features and come back and display this real quickly. Now, one of the things that's really cool if you were paying attention in the plenary on Tuesday is some of the new capabilities in GP and their scripting, the if-then-else capability, right? They give a better switch yard. When this was written prior to 2.1 in that logic, it was a very difficult conditional operator in the GP model. So it actually went down every path and only returned this set. But with that new if-then-else, this tool will run much faster because it knows only to go down my seasonal branch of that trace. So you can see now that I did the winter circuit trace and how it also picked up this circuit, this subdivision, this part of the circuit. Still terminates there, where again, finally, I can run the current operational circuit. And essentially, I think it's going to go more down here. So what I was trying to highlight here in this demo, not only the configuration, the simplicity of trace configurations, so you don't have to be a computer scientist to be able to write complex code anymore to do the type of traces you want to perform. Show you how easy it is through the geoprocessing models in the gallery to create these so you can push them out in your projects. So when I save this project and share it as a project package, to get that turned on, I just got to come back over here and turn on my operational circuits. And there, you can see how on the tail, it now traced on that part. I showed you how easy it is to customize the gallery. We'll be also extending the capability of the galleries, hopefully in a short-term release, to be able to plug in your own add-ins if you wrote something through the managed SDK. Because the managed SDK does run faster than going through a model, which is going through all the scripting within the model. And then I showed you, again, multiple configurations of the utility network based on your analytic requirements and the power of the utility network there. All right, I went a little long. You are more than welcome to ask questions and hang out. Jeff.
Can you demo or explain how to use the bitset network attribute?
Okay. The answer is no, Jeff. Jeff is asking if I would demo using a bitwise operator that we perform. And I'm not going to go into a bitwise discussion with him. Anyone who wants to know about bits can go to the island and talk to another developer. Any other questions? I can only say no to him because I know him. Yes?
The first traces that we ran, they were server-based and the Geoprocessing tool.
The first trace I ran was the Subnetwork Trace. I couldn't hear the second part.
Was it run on the server?
Yeah, everything you saw was running on the server. Even the model that I built. Everything is running against the services.
So my subsequent trace is if I choose the wrong criteria, I can bring my server to the
That is a very good question. What if I'm not thinking too clearly when I configured my trace? And a perfect example is a connected trace. Hey, just put this trace starting point here. I want to do a connected trace. And it's going to trace 5 million, 10 million, because whatever is connected. Now, how does server work? Server has, at the configuration of the server, timeouts for the sock. How long any one operation can hold a sock. Those configurations still apply. So if that trace is going to exceed, I think the default is 10 minutes? 10 minutes, yeah. It would get killed and you're going to get back an error. In that case, the trace would probably complete. Where performance would die is the JSON, the bundling up of all the JSON to send back to the client. Things that we're looking at to optimize in future releases. Feature services introduced pagination a couple of releases, so you could fetch a range of features at a given time. We know we need to build something like that into the trace call itself to the REST endpoint. So good question. Don't be shy. Come on, there's got to be. Guys, you can ask anything about the utility network. It doesn't have to be about just this demo. Or you can just sit here till 4 o'clock, or you can leave. I don't know.
I get confused when I write tracing algorithms and I'm working with the geometric network. What I get confused when I think of what's in the SDE, the database tables, how they're organized, and you say the network only exists in a web service. And I go, there's a relationship. I think the tracing, I want to say the tracing happens in the web service, but the network is defined by the data model. So a connectivity that's done with how we design our feature model, what we load in. The data model, you say, no, it doesn't exist there. It just exists in a web service, but it talks to a database, doesn't it?
Yeah, good question here.
Doesn't really make decisions. It just exists in the web service. That's where it lives. And you go, no.
Okay.
It's based upon a data model, a database.
So Andrew's asking a question, if I can briefly summarize so everyone can hear what was asked. He was talking about not only is the trace taking place on the server through the REST endpoint, through the services architecture, the configuration and creation of the utility network is also very new and different how we did things with a geometric network. When we create a utility network, we have to configure the domain network. When creating a domain network, we only give you 4 feature classes to work with. So within those feature classes, we have what's called asset groups and asset types, which are all used to represent the things that we're modeling in the real world. And the utility network only works in ArcGIS Enterprise. So it will only work in an enterprise geodatabase, which is part of our historical SDE, right? So it resides as a collection of tables and feature classes. It's the exact same feature data set model that we've always had in the enterprise geodatabase. Now, the difference is when you create and configure your utility network, you're going to do that in a client-server connection in the back office as the administrator. I will create and configure and deploy. We also have what are called asset packages to help simplify this deployment pattern that our partners will leverage. Ideally, you'll leverage those as well because they're better structured for understanding the metadata of your utility network over time. But once it's created, configured, and published, it is then essentially read-only in client-server. So you cannot edit your data in client-server. You cannot trace your data in client-server. That's why it's a services-only architecture. And once it's published, that's what creates the services. Then clients like Pro that know how to consume those services, as well as the custom applications you write that will consume those. So when you want to edit that data, you will be going through the feature service. When you want to render that data, yeah, you can pull back images from the map service if you wanted, or you can pull back features from the feature service. So that's why it's a services-based architecture, but there is the back office administrative steps that are performed client-server. And it's the same geodatabase feature dataset, feature class model with geodatabase domains, subtypes, default values, new things like attribute rules that you can leverage. So, that answer your question, Andrew? Sort of. Somebody will help you more. Did I see another hand? Yes. How is the configuration model handled? All configuration, so with ArcGIS Pro and the utility network, all configuration is done through geoprocessing tools. So all DDL, data dynamic language, changing of the schema is done through geoprocessing tools in client server. Oh, yeah, that's what I'm talking about, the configuration of the network. So if we look at our geoprocessing toolbox, so utility network tools, right? If we expand that, you'll see we've got a lot of tools that are used for creating the utility network, adding tiers, domain networks, but also the path that we're recommending is these asset packages that are provided by our solutions team. It's a starting point, it's a foundation that you can configure the utility network in these asset packages, and then they run, and they simply call through Python all these same tools. So if you want to build your own utility network, if you're a partner or a distributor who's configuring something, I'll pull this one out of the air. Steam networks, right? Well, solutions team, they don't provide a Steam network model yet. So how would you go off and build it? You could build it with all these tools and then export it to an asset package and deploy via the asset package model. So, yes? Oh, right. Yeah, good. Yep, good. Very good question is, when I performing these trace operations, and let's say I'm writing my own app against that REST endpoint, well, the result set of the trace will be the features. You know that, but you don't have the direction yet. One of the things, and we're augmenting the outputs of all the REST endpoints. Like maybe I want to do a trace, and I want to get a diagram back, not the features. That could be an output option. Maybe I want the JSON of all the features back, or I want the graph itself back. So those are all things we're building on to the REST endpoint as output options. Right now, the REST output for a trace is a collection of feature IDs. And then you take the feature IDs, and then you got to go pull those back from the feature service itself. So, sure. The first part of the question was tracing in a version? Okay, I heard that. So remember, here in Pro, since you asked that question, right? I've showed you all this tracing, right? But I can come here and change version and pick a different version, as this is going to the version management service, hopefully, yeah. But that trace would perform exactly the same. All of our REST endpoints take a version name as an argument. So if I want to trace against my design version to do that trace, wow, having problems there. Loading versions. So if I go to this, whatever, I don't even know what I got. These are old. It just works, right? It's still just the same trace with whatever trace configuration working on that name version. And the utility network requires the data to be versioned before publishing and sharing, right? It's a configuration. And that's what supports our editing models, our undo redo, design versions, long transactions that work completely through a web, a service architecture. The second part of your question was about propagators. That is a very advanced topic. Propagators, and briefly what a propagator does is based on the configuration of the trace, given the field that you want to propagate, like a phase value. Starting at a location, as I propagate along, let's say at the circuit breaker I was phases A, B, C, but then I came to 3 fuses and the B fuse was open. Well, the electric, is being transmitted, well now it's only A and C. So the propagation is now just AC. So propagation is very important for configuring a North American circuit. You can do propagation, for example, we were talking to a partner earlier today, taking like a pressure level and maybe propagating out the PSI by taking the max value and then propagating that out. What's also powerful about propagation is when I maintain these subnetworks and update them after I validate the topology, we take that propagated value and we can burn it in and store it at the feature level. Well, it does work on the version model as well. for features that have been touched. So that was a good question.
So you said versions within the base stock geoprocessing. Can you write your model?
Can you write your model to work with a specific version?
Yeah, this always.
The geoprocessing just simply works against the workspace that was opened. So if you write a model that takes a connection, which has a property set of the name of the version that you want to work on, when it makes that connection and opens the workspace, then everything performed goes against that version. Yeah, because all the geoprocessing tools you see in Pro are bound to the map that launched the tool with the inputs. Because the input utility network to that trace tool was using, remember here, the input utility network, I'm choosing that from the active map. And that utility map now is work order 020305. So again, it's always the inputs and what workspace was opened. So same model that we've always had with versioning, with traditional versioning. No new concepts with the versioning. Well, if no more questions, feel free to come up afterwards. Thanks for attending. Enjoy the party tonight.